my name is Carrie Ruggles. I am a data engineer and analyst at Hospital Sisters Health System and a Master of Public Health student at the University of Memphis School of Public Health. And my project right now, I am fortunate to have access to an absolute ton of data for the whole hospital system through work. So I am able to do my thesis project through work, which I'm doing on EMR surveillance of hospital-acquired pneumonia, leveraging the National Health Safety Network clinical definition of pneumonia. To make the abstract brief, many instances of hospital-acquired pneumonia are preventable. And ventilator-associated pneumonia has been studied extensively because the definition is more concrete. But the non-ventilator-associated hospital-acquired pneumonia has not been studied nearly as much. And the studies from ventilator-associated pneumonia are not generalizable to non-ventilator associated hospital-acquired pneumonia because of the different causes. So the goal is to identify which patients are high risk while there is still time to take preventative action, and to communicate to the providers who is at high risk so that they can take what they see as the appropriate action to improve patient safety, reduce adverse events, and lower healthcare costs. Okay, so problem statement, of course, is hospital-acquired pneumonia is the most common hospital-associated infection in the US and the second most common globally. And although an estimated 2/3 of hospital-acquired pneumonia is non-ventilated, the majority of the research focuses on the ventilator-associated pneumonia. And the majority of hospitals, including the hospital system I work at, lack a formal surveillance and prevention program for hospital-acquired pneumonia that is not ventilator-associated. And both my hospital system and really anywhere would benefit from a centralized methodology for surveillance and prevention of hospital-acquired pneumonia. So the major part of the hypothesis is that making the care providers aware of which patients are at higher risk will help to guide the care provider's decision making. There is precedent for this. There's similar research that showed successful results that were actually tested in one and successful results that were modeled in another. And these were back in 92 and 96. So if that can be done to an effective level with the paper charts and bedside calculations they were doing at that point, surely we can make it even more accurate and effective with the technology we have today. Similar research has also shown that even when only focusing on the highest risk patients, benefit is still seen by all patients. Also, precedent for awareness resulting in people taking action, even if it's subconsciously. And in this case, I am not asking the care providers to do anything in particular. We would just be reminding them of what the standard hospital-acquired pneumonia prevention protocols are and letting them use their best judgment and experience that I don't have because I do not have the clinical background like the nurses do, the doctors do. I definitely don't have that clinical background. So for my master's thesis, I'm currently in the retrospective portion. I am extracting and analyzing baseline data from the electronic medical records, data from 2022 to 2024 from all 13 hospitals, and using the NHSN clinical definition of pneumonia for identifying cases. At the same time, we are working on developing the intervention with an interdepartmental work group. It's the specific parts of the goodness, of the algorithm that we will be identifying. For example, age can make a difference. Smoking status can make a difference. Underlying conditions can make a difference. So we will be playing around with that algorithm once all of the baseline data is finished. And then for the prospective portion, we will be doing a 1-year clinical trial, a stratified random sampling of the trial hospitals. The remaining hospitals will serve as controls, and monitoring, myself and the infection prevention team will be monitoring daily, and the trial hospitals will get reports on a monthly basis. And then, of course, at the very end, analyze that year of trial data, comparing it both to the individual hospital's baseline data and the control hospital's data during the trial. And then the team will make recommendations whether the research should be continued in place, whether it should be expanded to all of the hospitals that have room to decrease the incidence rate. That'll make more sense later. Or whether it needs more research. So what is hospital-acquired pneumonia? Specifically, it is pneumonia that develops at least 48 hours after hospital admission. And like I mentioned, I'm focusing on non-ventilated patients. And it is so important because there are major costs to everybody involved. There's a patient with hospital-acquired pneumonia averages 6.5 extra days of hospital stay, or 68% longer stay. ICU admission in almost half of cases that otherwise would not have required it. 15 to 30% higher mortality rate, higher 30-day readmission rate, higher monetary costs for the patient, for Medicare. The research only looked at Medicare, not other insurance providers, and higher costs for the hospitals, especially because hospitals are generally not reimbursed for costs related to hospital-associated infections. And then there are non-quantifiable costs like productive time lost and quality of life. So Hospital Sisters Health Systems is a system of 13 hospitals across Illinois and Wisconsin. They vary widely. 4 of them are rural, considered critical access hospitals. There's different levels of trauma centers. Size range from 3 to 34 ER stations and 25 to 517 inpatient beds. Very wide range of inpatient stays from a little over 200 to a little over 1,400. And the average hospital-acquired pneumonia instances per year are anywhere from 1 to 2,400, which is an incidence rate of 0.11 or up through 15.38. So that is quite a gap, and I personally like the lower number better. With being at such a large hospital system, have the benefit of being able to put the intervention into place at multiple and varied hospitals and still have control hospitals to compare against. And we have the opportunity to set the bar for future studies, both on hospital-acquired pneumonia and within the hospital system itself. So for identifying hospital-acquired pneumonia, I mentioned I'm using the clinical definition from the NHSN Patient Safety Component Manual, which comes from the CDC. I'm using the 2024 version because that's what was out when I started coding everything, and I'm not starting over for the changes. But they're not major changes, and it lets us standardize the diagnoses across hospital to hospital and observer to observer, and to be in line with what the reporting standards are. But this still poses difficulties. So the criteria can be amorphous and subjective. Some elements are not documented in the electronic medical record, either consistently or sometimes at all. They may be in free text fields instead of in codes, or maybe sometimes one, sometimes the other. Inter-observer variability is high. For example, what is considered a worse cough if, say, it's your first day on in a week, what's a worse cough? And it has a low sensitivity and specificity as compared to histology, which is taking a tissue sample and culturing it and looking at it under the microscope. And this all presents a major barrier to the surveillance and prevention programs. So here is a tiny taster of what makes this, are all on. So the entire hospital system is on the same instance of Epic. So yes, same EHR and same release. Thankfully, makes it significantly easier. So there are 3 parts of a clinical definition. There's imaging, which is primarily what I'm looking at today. There's signs and symptoms, and there's laboratory testing. Here is an example of one of the flow charts. It doesn't even fit on my screen at this magnification. And so you step by step, and there's different paths for if this, if that, and it is not a clean decision tree either. That was, let's see, patients of any age. I seem to have the image in there twice. Another difficulty is some things are defined in great detail, and some things are defined like this. So if a patient is immunocompromised, that immunocompromised definition, a number of things rely on that, and this is the entire definition, is one footnote with a handful of bullet points. So you have things like patients with neutropenia defined as such and such, but it doesn't say, for example, what time frame that's in. So one surveillance system could be doing it, anytime in the last 30 days. Another could be doing it during the same stay. Another could be doing it within the past 3 days. It's not so very specific there. So we've had a lot of back and forth deciding on those. Not want to the edits. Fantastic. We are frozen again. All right. There we go. Did I go? Okay, only went forward 1 page. So some considerations for the natural language processing of the clinical impressions and findings of X-rays. So these are not coded. These are put into free text fields and then just dumped into a single column. Everything is dumped into a single column, formatting and all. And there are a long list of, I don't think this is even the full list anymore, of terms that I'm looking for within those text fields, along with misspellings, abbreviations, similar phrases. The NHSN definition only includes the 4 terms infiltrate, consolidation, cavitation, or pneumotoceles. Probably didn't pronounce that one right. And it specifies that it must include the terms new and progressive or progressive and persistent, but this does not reflect the reality of things, how things are actually recorded in the X-ray interpretations and findings. So first thing I did was, extracted from the database and de-identified everything. Pulled it in over here, put it into a, on that step, so I can get, yeah, that's, there we go. So there are 240,000 rows in here, and each row represents one X-ray order. So if patient has, say, come out of surgery in the morning and they need X-rays to check up on the surgery, and X-rays are ordered then, that's one order. If later in the day they start looking like they're feeling terrible and the doctor wants to do another set of X-rays, that's a second order. So those will be each considered separately. And so here's what they look like. Project ID is useless for anything but tying it back to the identifiable data. So we could have things like, I mean, none of these are very similar except for the words findings and impressions initially. So the important part is the column definitions. The project ID combines de-identified versions of encounter ID, which is a single continuous inpatient stay, and the order ID. The infant flag, 0 for no, 1 for yes, because part of the clinical definition includes an extra search term for patients less than or equal to 1 year of age. And the impressions is the free text field. I've actually included impressions and findings. And it is the interpretation of what is seen in the x-rays and what it likely means for the patient's health as determined by the radiologist. So that one's going to work right now. Oh, wait, there we go. So here's an example of a random one. It's just, like I said, I'm not clinical. To me, it's mostly word salad. It's less word salad than it was 6 months ago, though. So the first thing I did here was to separate each of those into individual sentences. And to take a look at that same one from before, each row is an individual sentence. And then each of those sentences is going to be interpreted separately. And then the interpretations will all be put together. And then, let's see. And I just put everything in the impressions column to lowercase, so I don't have to worry about telling it to ignore case every step of the way. And then we can look at things like how many infant orders are there. There's 14,775, which is a little over 6% of the data set. Then the next step is to extract only the sentences with the relevant terms. So these are all the search terms. These are the ones from the NHSN definition. Then there's the modifiers, and then the list of name versions and acronyms and abbreviations and misspellings and all that jazz that I came up with from looking at the data. And then I join everything that I'm using into one list. So then I identify anything that has any one of those search terms in it. So to just look at the rows that aren't empty sets. So this is only showing me for each row the sentences that have a relevant search term in it. I am running out of time. Yes, so this is the fun part. And so in this case, I am looking for three different things in relation to the search terms. I'm looking for negation, whether it's positive, negative, or neutral or unsure. And then I'm going to look at that in two different ways. One way is if there's any positive, it's counted as positive. If there are, the other is to take the score of each sentence, sum it up, and if it's greater than 0, it is positive. The hospital acquired from a community acquired pneumonia, especially in cases where symptom onset is unclear. So that gets really detailed, and it has to do with an infection window and all of the symptoms, the signs and symptoms, laboratory tests, and imaging has to be within a certain time frame. It's usually, I think it's 3 days before through 3 days after the first positive imaging test. So I only did the negation sentiment for this because it gets pretty detailed. So I found that thankfully for this, the built-in classifier was pretty accurate. So I used the classifier. I changed the results to integers. With indeterminate, most of them seemed to be a positive result, but I need to have someone with more clinical experience go over that as well. So you look at with any positives, and then here's a look at both the data sets with the same 10 rows and how those results shake out. So pretty different. Well, as you get farther down the line, it gets more and more different. Certainty and temporality, I just have dummy variables in here right now. I used random variables because the calculations with everything was, they've been running for a day and a half in the background. Thank you, Jane, as well. If you have any feedback, I would love to hear from you. I will be sharing this notebook as well. And then I took a look at the sentiment. Oh, dang it. Okay. Let's see if these will run quickly. No, I've got other stuff. But this was supposed to have, and will in the notebook that gets shared, it outputs here the ones that are determined positive based on the negation sum method and the ones that are determined positive based on the any positive method. Let's see, to help decision makers trust results, do you have a sorted order to the radiological reports related to your derived classification? So we're using their, yeah, thank you, Sean. I don't know if they're, if somebody can invent that, they should start their own EMR and make bank, and they will never need to work again. Audrey. So in cases where the patient was, distinguishing hospital acquired from community acquired pneumonia, in cases where the patient was recently discharged, on down the road, I am going to be looking for readmissions. And if it is within the right infection window, then it'll be considered. But that is a short infection window. So they pretty much have to be discharged and then readmitted within a day or two. As far as the difference from community-acquired pneumonia, it's that definition of the 48 hours, no sooner than 48 hours after admission. And let's see real quick. I think all I have left is, so here was the important part of this one. So I did this is the very preliminary numbers of the retrospective data, and I found these 3 clusters. So this black circle down here, they don't really have any farther down to go. So they'll be excluded from selection as trial hospitals. But this red cluster and this green cluster, I find it interesting that they're very different. I suspect that with the green cluster being the larger hospitals, that is likely where our infection prevention specialists are stationed. So they get more attention whether they want it or not. And so that will likely be how the hospitals are stratified to randomly select from there. And then my references need to be updated. So thank you for everyone who made it. Feel free to message me, absolutely, if you're interested discussing any of it. Thank you.